So in this video we're going to tackle what has got to be the coolest problem in anybody's first semester of physics, orbit. So we're looking for what speed you have to stay in an orbit h meters above the Earth's surface. Alright, so we're looking for a velocity, and this is an orbit, so I'm going to start by drawing that. Here's the Earth, can you tell? Here is our orbit, circular orbit. Will be right here, perhaps, going at a velocity v, and we're a height h from the ground. So we're looking for what that v is. So let's try a free body diagram. So that's the path of the orbit there. And, well, there's certainly gravity pulling us down. Here's the mass of our satellite, or I'm just saying us, I don't know if we're flying around up there or what. And here's the force of gravity. Okay? So that's the only force on here. I'm going to go ahead and define my axes. Now, since this is a circular motion problem, I'm going to make sure and point one of my axes toward the center. I'll call that the C direction and the Y direction, so that when I do the sum of the forces in the C direction, I get is equal to MAC. And then I recall, oh, the sum of the forces in the C direction can be written as mv squared over r, where r is the radius of your circle. So now that I've done that, I should probably represent the radius of the circle in my problem. And so it'd be from the center of the Earth there. Okay, and I also know that from my problem, the sum of the forces in the C direction is just Fg. So looking at this, we have that mv squared over r is equal to the force of gravity. Now, the force of gravity is not going to be simply mg. That only works at around the surface of the Earth. When we're this far away in orbit, we need to use Newton's law of gravitation. G, mass of the planet, mass of the satellite, over the distance between their centers squared. So looking at this, this r and this r, that's the same. I can multiply through by an r, and I can divide through by m. Both of these m's are the mass of the satellite. So we didn't need to know the mass of the satellite. Looking for v here, we have v is equal to the square root of gm over r. But r was not given. We were supposed to find it for an orbit h. We made up r. But if I look over here, it looks like the only difference between h and r is the radius of the Earth. Right? So r is equal to the radius of the Earth plus the h. And then I will have answered in terms of what the variables I was given. So the velocity is going to be the square root of g, mass of the Earth is what that is, over the radius of the Earth plus h. And so that is the velocity that you need to have in order to orbit up at height h. And all the rest of these are constants. G, the mass of the Earth, and the radius of the Earth aren't changing, we hope. And plus h, so plug in h for wherever you want to orbit, and that's the velocity you need to have. Fun.